So we just finished the sorting of the graphs. If you wanted to see a video of how one of the classes did it, then look at another link on the video. On the blog or website or whatever. So 1.2 notes. First thing that we have to know, and you're going to write this down in your notebooks, is functions. Functions versus relations. Versus a relation. And what I call this thing is just a not function. So what a function is if you take something and do something to it, only one thing can come out. Like, for example, if you were at the grocery store buying milk, and you bought milk and it cost, let's say it cost $2, and then somebody else bought milk behind you and it only cost them $1.90. Same exact gallon of milk. Is that fair?
No.
No, that's not how it works, right? So the function, like the price thing on the thing, only has one result. So only one thing. But how we tell with graphs is something called the vertical. So vertical line test. For funsies, if you want to call it the VLT, you can. The vertical line test says that if you have a function, a graph, so something like this, and let's just say that we have the Harry Potter lightning bolt scar thing, right? So you have this one. I think this is graph C on the ones that we just organized. The vertical line test says that if our graph, which is just the lightning bolt looking thing, if there is a vertical line that we can draw anywhere on this graph, so you don't have to draw these yellow lines. I'm just saying vertical lines, so that goes up and down. So a line starting from the top, dropping to the bottom. Imagine that this is really like you're holding a really hot marble at the top of a graph. And that the graph is made of something like wax. What would happen if there was like a line that you dropped a line of wax that you dropped hot marble through? What do you think would happen to that wax? It would melt and go through once, right? If that marble would fall through and melt through two different places on the graph, it's not a function. So is there anywhere where a vertical line on this thing went through more than once?
No.
No, so that means that this is a function. It passed the vertical line test. On the other hand, there's the graph that looks like this. If that was a graph that we had, and we dropped a vertical line, drew a vertical line, or dropped that hot marble through there, how many times is that one going to go through the graph? Twice. So since it went through twice, or just simply more than once, it is not a function.
So it would be a relation?
It would just be a relation, yep. And then if I went all crazy and I had graphs that looked like this. What? Is that a function or not a function? See, because no matter where if you can find anywhere on the graph. Because see if I drew it all the way over here on the left, see how it only crosses through once? You can't be like, well, it only crossed once right there. That means it's a function. The vertical line test says if you can draw a vertical line anywhere on the graph and it crosses more than once, that means it is not a function. Or if we had something like this, so it looks kind of crazy, but is there a vertical line that you could draw anywhere on that where it would cross more than once? No, so that means that no matter where we draw the vertical line, it is a function. So I want you to sort through your graphs right now and sort them according to function and not function. Yeah, the ones that we just sorted. Sort them again according to function and not function. For the sake of time, we're just going to say, I want you to just write the ones down that are not functions. Which ones are not functions? E is not, N is not, J is not, and R. Why is R? R is the vertical line. How many times would a vertical line cross a vertical line? Always, right? Because it is a vertical line. And so it's going to...
it never passes through it. It's always in it.
Yeah, but for time,
It's in it. It is a vertical line. It crosses an infinite number of times. Does that make sense? Which is for sure more than one time. Okay, so the knots. Those are the ones that are not. Okay, next part. Rate yourself on how well you feel about functions versus rate yourself on how well you feel about functions versus relations or not a function. 1 to 5. 5 means you get it. 1 means that you're lost. You probably couldn't figure out function versus not if it was hitting you in the face. Okay. All right. So it looks like we're good. Next part is very easy. I think it is discrete versus continuous. Basically, the discrete functions are the functions that are just made up of the dots / points, and they're not a line. Continuous is basically a line. There's more to it, but this is all we're going to go into it for now. So discrete versus continuous. Which ones are discrete? Well, so go through your graphs and sort through which ones are discrete. So discrete are dots and points. Continuous is a line. The ones that are discrete on our ones that we sorted were K, F, U, and O. So discrete dots. Continuous basically a line. The next part that we are learning after discrete and continuous is there are 4 different parts. There's increasing, decreasing, and some group had increasing and decreasing. I like this one. Increasing, decreasing, both, or neither. These are all related. So when you're looking if a function increases, decreases, has both or neither, you always look from left to right. You look from where to where?
Left to right.
Okay, so as you're looking from left to right, if it goes up from left to right, and I'm just going to put it up like this, if it goes up from left to right, it is increasing, even if it's a curve. As long as it goes up from left to right, it is increasing. Decreasing means it goes what?
Like down.
Down. So you're always going from left to right, just like you're just looking from left to right and see, does it go up or does it go down? If it does both, it could be like one of these, or it could be, you recognize those, or it could be one of these. It increases and decreases. What kind of graph looks like neither?
What?
What one?
Just straight.
A horizontal line. Question? Do you guys remember positive, negative, 0, undefined from last year? Okay, questions. Oh, I love these questions. Okay, Case.
Would a vertical line be both?
A vertical line would be, that's a really good question. It's still undefined.
So it's
A
not
vertical line is nothing.
It's not neither.
It's not neither. It's just undefined. It's none of the above.
What would a circle be?
It would be both increasing and decreasing. It's not a function also. The circle's not a function. Other questions? Is that what your question was? Did I answer yours? Okay. Any other questions? Okay. Rate yourself on how well you feel with your ability to tell if something's increasing or decreasing, both or neither. Okay, 1 to 5. Looks like we're doing good on this. Last part is we have to talk about the domain and the range. So the domain, these are a whole bunch of other words for domain. The domain could be the x's. It's also, the domain goes horizontally. What other one goes horizontally that we did in last lesson? What goes horizontally?
Independent.
Good, independent. It's also the inputs. These are the ones. So like the inputs, the x's. Like if we had some function 3x plus 5, the x can be whatever it wants to be. Anything. X can be anything. That would be the domain, can be anything. But what does change are the y's. So x, independent input, a domain, horizontal. Okay. The range would be the y's. It's dependent. And they're the outputs. In fact, in terms of a function, I want you to put this on here somewhere, a function says for every, can I teach you a really cool thing for every? For every is an upside down A, and that stands for every. For every input, there is only one output. That's what a function is, but a relation says for every input, there is just there are outputs. There's an output. You could have two outputs. It doesn't matter. There's just an output. Output. Okay. So your homework for this section is the same type of thing that we did last time. So there's the vocabulary. That's kind of a matching part that has to do with these words that we just learned. So like the function, discrete, continuous, increasing, decreasing, both, or neither, domain, range, input, output, function, relation. The next part of the first lesson says, so the first section of homework says, somebody decided they sorted graphs and they put these two graphs together. Why do you think they put them together? So the things that I want you to talk about when you're doing these things, and I'm going to slide this over. On these things, you need to talk about why they, and I want you to talk about if it's a function or not. I want you to, function, is it discrete? Is it increasing or decreasing? Are you guys okay with INCR for being increase and DECR being decrease? Okay, increasing or decreasing, or both, or neither. Increasing, decreasing, neither. And then the shape of the graph. And the shape is kind of the categories that we did. So why do you think they would have put these two graphs together? First of all, are they functions? So, yeah, we're going to put both are functions. And then, Case, what were you going to say?
I was going to say they're both increasing and decreasing.
Good. Both are functions. Both increase and decrease. Why else? Are they discrete or continuous?
Discrete.
They are continuous. And then, what is their shape? How could you describe the similarities in their shape? I would say they point up on both sides. Should we put point up? They kind of point up and out, but they're not pointing down for sure. Do you guys see that? They both point up. So I want you to talk about those four things with those. This is the hardest part of the homework, is just figuring out those things to say. But if you're always looking, are they a function, discrete, increasing, decreasing the shape? It's really not very hard. The next section, just look at the next section. The next section, I'm pretty sure you can do in about 30 seconds. You're just supposed to tell if it's discrete or continuous. Which one's the only one on here that's discrete?
11.
And then obviously 7, right? So that's the end of that. Then the last part is you're supposed to tell if it's a function or not. That's what the last section asks, is to identify which ones are functions. So turn to the last section. So this last section, determine if each graph represents a function using the vertical line test. Which ones are not functions? 14, 15, and say it again over there?
17.
And 17. Okay, everything else a function. That's the end of the homework. I bet you can get it all done and like way done before class is out.